In a world of memes and YouTube, it's almost impossible to get anything done these days. Social media is flooding our potential work time with pictures and videos that keep us from more important things, our physics homework. Luckily, a recent study in Japan has found a solution for us. The Power of Kawaii, a study from Hiroshima University, tested 48 university students and discovered that viewing cute images of animals like kittens and puppies will make you more successful and more focused at your task. You normally wouldn't consider kittens as being physics geniuses, but today we'll embrace the idea and hopefully find some kind of focus to get a few physics problems done. Warning, we are going to be doing math, but I promise all math will be accompanied with cute kitten visuals. Meet Noodle. He'll be our scientist for this. Noodle is a kitten and very cute, so he might help us with some productivity. We'll start off with a mass versus weight question. We'll be using gravity. On Earth, gravity is measured at 9.8 meters per second squared. So keep that in mind for this next question. Noodle weighs 8 pounds. What is his mass? To start, let's convert Noodle's weight from pounds to newtons. 1 pound is equal to 4.44822216 newtons. Multiply that by 8 and we get about 35.59 newtons. Weight and mass may seem very similar, but they're actually quite different. The mass is how much matter makes up an object, and weight varies based on gravity and where you are. You can measure weight by multiplying mass by gravity. We know Noodle's weight, so to solve for mass, let's divide both sides by gravity. Then end up with the equation mass is equal to weight divided by gravity. We divide 35.59 newtons by 9.8 meters per second squared, we get 3.63 kilograms. So Noodle's mass is 3.63 kilograms. Now let's look into velocity. We'll be using the program tracker to find out how fast Noodle can run. Once you get the video imported into Tracker, you can set up your measurement calibration. You do this by selecting the 10 with a line and click Calibration Tape. The tape measure is set up to 1 meter. I'm then going to move the calibration tape up to my meter and stretch it out for the length. Tracker will now reference this for distance. Next, we need to set the Y and X axis. You do this by selecting the Axis tool and dragging it over to where you need. Once your axis is set, you can start tracking motion. Go to Tracks, New, Point Mass, and scroll into the video to the point where your motion begins. Once we find the first frame of movement, hold Shift and the clicker will turn to a plus. Click the tip of Noodle's nose and Tracker will automatically jump forward to the next position. Keep going until Noodle is out of the picture. Notice that each time we mark a position for Noodle, the coordinates are added on the right in the graph and on the table. The X along the left stands for the position, and T on the bottom is for the time. We're going to use these values to estimate the velocity. You measure velocity by dividing the change in position by the change in time, or x final minus x initial divided by time final minus time initial. We're about to do some more math, so here's some more Noodle. Let's plug in our first set of coordinates. 0.18 meters minus 0.02 meters divided by 28.49 seconds minus 28.45 seconds. Calculate that and it equals 4 meters per second. Let's use the next set. 0.81 meters minus 0.18 meters divided by 8.61 seconds minus 28.49 seconds, and that equals 5.25 meters per second. And one last set, 1.76 meters minus 0.02 meters divided by 28.82 seconds minus 28.45 seconds, and that equals 4.7 meters per second. Let's get the average. 4 plus 5.25 plus 4.7 divided by 3 equals 4.65 meters per second. Let's compare this to Tracker. Click the graph and select Analyze. Then make sure to select Fit and Auto Fit. Tracker will then plot the best fit line through our data. Once it does this, Tracker calculates the slope, which coincidentally is also the measurement for velocity. So 4.622 is what Tracker came up with, and 4.65 meters per second is what we came up with. That's pretty close. That's it for Kitten Physics with Noodle today, but join us next time as we take a look at the energy in a pendulum, and stay tuned, we'll take a scientific look at this collision.